So guys, now we're at question number 10. Question number 10 is as follows. Uh, we got a gas cylinder, and this gas cylinder has got 30 liters of oxygen and also 18.20 moles of oxygen. Now some of the oxygen is removed from the cylinder, so that what happens is the gauge pressure has reduced to 11 atmospheric pressure. So we need to find how much amount of mass is taken out of this cylinder. So let's find it out. See, first of all, use this equation PV is equals to nRT, so that you will find the number of moles in this given gas. So pressure is given to be 11 atmospheric pressure. So 11 into, how much is this? This is 1.01 into 10 to the power of 5. The volume is 30 liters. So I write it as 30 into 10 to the power of minus 3 is equals to N into R is given as 100 upon 12. So temperature is 27 degrees Celsius, which is 300 Kelvin. So 30 ones, 30 tens, and now we get 3 cancel. So we get this gets cancelled with this, and you get 2 here, and then you get minus 1. But take this here, then I get minus 1. So that you get N is equals to 12 times 11 into 1.01 by 10. So let's use the calculator and do the quick calculation. This quick calculation, which is 12 times 11 times 1.01, which turns out to be 13.332. Now this is the final number of moles, and they have given initial number of moles, which is, how much is initial number of moles? Initially there are 18.20. So the number of moles that I have taken out from this gas cylinder is 18.20. Delta, I write it as delta N is 18.20 minus 13.332. Let's use the calculator again. Calculator, first divide by 10, when you subtract 18.20, and this is how much we are getting? We are getting 4.868 point something. Now you got the number of moles that you removed from the system. Once you know the number of moles, now you can use number of moles is equals to mass by atomic mass, molecular mass. So number of moles is 4.868 is equals to mass that I have removed by atomic mass is given to be 32 grams. So mass turns out to be how much? Let's again do the quick calculation, which is approximately 0.156 kgs, because I am getting it as 156 grams, which is 0.156 kgs. So which is option 3. Now question number 11. 11 is quite simple. We got 4 lengths. Question number 11 is quite simple. We got 4 lengths, each of P, whose power is P. Now if I combine them together, the effective power is given by P effective is equals to P plus P plus P plus P, which is 4P, and effective magnification, M effective, will be M1 into M2 into M3 into M4, which is M into M into M into M, which is M to the power 4. So this is quite easy. Now question number 12, this is little interesting. Now we got a circuit as follows. We got an inductor here, and we got a battery, and also we got a resistor. So let's say this is point A, it is given as a point P, and the current in this circuit is 2 ampere, and there is an inductor in which the current is increasing at a rate of 1 ampere per second, and this is 5 volt, and this is 2 ohms. Now let's apply the Kirchhoff's law. Let's start from here, VA. Now since the current is increasing, the inductor tries to oppose the increasing current. So here it will produce a positive terminal, negative terminal. Now this is VA. Now since we are going from positive to negative, you write it as minus. And EMF induced in inductor is given by EMF induced, I'll write here, EMF induced E is equals to L di by dt. So L is 1, what they are given is L is 1 Henry. So 1 into di by dt is 1 ampere per second, and you are going from positive to negative, so this is minus 5, and minus I into R, which is 2 into is 4, should be equal to VB. So VA minus VB, which should be 5, 4, 9 plus 1, 10 volt. This is what they are asking. So VA minus VB is 10 volt. Now let's do question number 11. Now we are at question number 11. We are just now done with question number 11, right? Question number 11 and 12 is also done. 12 is also done. I will go through question number 13 now. Let's go for question number 13. So in question number 13, there is a body and whose weight is 48 Newton on the surface of the earth. So weight is given by weight is equals to G capital M small m by the radius of earth whole square, which is given as 48 Newton. And what I need to find is weight at a height equal to 1/3 the radius. So weight at height h, which is equals to G capital M small m by R plus what is the height? I need to find weight at a height equals to R by 3. So R plus R by 3 whole square. This value I need to find. This is G capital M small m by R plus R by 3 is 4R by 3. 4R by 3 whole square is 4 4 is 16. 16 R square into 9. So this is nothing but 9 by 16. There is R square. G capital M small m by R square. But we just now figured it out. G mm by R square is 48. So this should be 9 by 16 into 48. 16 1, 16 3 is 9 3 is 27 Newton. So this is your answer. 27 Newton. This is the weight that you would feel at a height equal to 1/3 of the radius of the earth. Now question number 14 is also quite simple. Let's write it here. Let's conserve some space and time. So we got equation. Input voltage is given by 220 sine 100 pi t. This is 220 sine 100 pi t. This is the voltage. Now, how do I find the voltage at time t is equals to 15 milliseconds? We need to find voltage at time t is equals to 15 milliseconds. So, voltage is equals to 220 into sine of what is 100 pi into 15 into 10 to the power of minus 3, because this is milliseconds. So, if you calculate this, this is 1.5 pi. 1.5 pi is minus. So, this is minus 220 volt. So, that means voltage is negative. So, if you draw the diagram. Input voltage, and here this is the diagram that they were given. This is load resistance. Now this is negative, this is positive, because we are getting negative minus 220 volt. This is negative. This diode is reverse biased, and this is diode D1. So D1 is reverse biased. I'll write here. This is reverse biased, and this diode D2 guy, this guy is forward biased. So this is forward biased. Now let's move on to one of the toughest question. The first advanced kind of question is question number 15. Let's get it done. You can solve this question in two ways. One is using relative velocity, which is quite interesting, but which I don't think most of the people would understand that way. But in this lecture, I will go through the classical method without using the concept of relative velocity. But in next video, I will use the concept of relative velocity. So let's understand the question. So in this question, what they are saying is, we got a person who is riding on a scooty. There are two cities, let's call it as X. And there is another city, let's call it as Y. And now there is a person who is moving. There is a girl. Now we got a girl who is driving the scooty. She is also driving the scooty. Let's draw the scooty. Now this is her scooty, and this is that young lady who is driving the scooty. Now she is moving with velocity. How much velocity she is moving with velocity equals to 60 km per hour. She is moving with velocity 60 km per hour. And what they are saying is there are two cities. This is X and Y. They both are connected by a regular bus service. So there would be some regular bus service, and the buses keep moving from X to Y after every particular interval of time. Let's say after time t, the first bus goes from here to there. And after next time period t, the second bus starts coming from here to there. And after next t, you will get another bus coming from here to there. And also similarly, simultaneously, you are getting the one bus each at a regular interval of time t. So at time t, let's say time t is equals to 5 seconds. So after 5 seconds, you will get first bus here, and next 5 seconds you will get second bus here, and next 5 seconds you will get next bus here. So this is how the process is repeating. Now what we need to do is, and they have given something else. What extra information they are given? So let's take the buses. So this bus, this is the first bus, which is moving in the direction of the scooty. Let's say this is moving velocity v, and she crosses this bus 2 times in the interval of 30 minutes. So this is the first thing that you need to know. And if the bus is moving in this direction, now she crosses this young lady after every 15 minutes of time. So these are the 2 points which you need to note. So let me redraw this diagram here. So let's say what happens while they are meeting. Let's say this is the girl, and now she is moving on a scooty. Now this is the bus. First time the bus has met here, and now the lorry or the buses are coming in this direction. So buses are coming in this direction. Now the distance from here to here would be v into t. This is the first important point that you need to understand to solve this whole question. The distance between these 2 buses, the next bus, let's say this girl is meeting this bus at time t, and on the distance from which the next bus which it is going to meet, let's say this bus is coming in this direction, she is moving in this direction, so this is going to be at a distance of vt. Now what they are saying is they both are going to meet after 10 minutes. So the scooty girl and the bus are going to meet at this point after 10 minutes. So what is this distance traveled? It would be, this distance would be her speed into time. Time is 10 minutes. 10 minutes is nothing but 10 minutes is 1 by 6 hours. So this distance would be velocity into time, which is 60 into what is time? 1 by 6, which is 10 kilometers. So this distance would be 10 kilometers. And what is this distance would be? This distance would be the velocity with which the bus is moving, which is vt. This is velocity is v. Into time taken is 1 by 6. So v into 1 by 6, which is equal to this distance, total distance, which is vt minus this distance, which is 10. This is your first equation. Now once you understand this equation, now your half the problem is solved. Now let's write the similar equation when they both are moving in the same direction. So let's write the similar equation. Let's say she is here when she meets the first time, and the second bus is going to be here because they both are moving in this direction. And let's say after some time t, they both are going to meet at this point. They both are going to meet at this point. Now this distance is vt. Now this distance, let's draw scooty in proper way. Now this distance, the scooty which has traveled, is going to be speed of this 60 into time to 30 minutes, which is half hour. So 60 into 1 by 2, which is 30 kilometers. This is 30 kilometers because which is 60 into 1 by 2, because 30 minutes is half hour, so 60 into 1 by 2 is 30 kilometers. And now this distance is going to be V into now what else we got? Now this is 30 and this has to come till here. So this whole distance would be how much? This is V into the time taken. How much time it is taken? This is 1 by 2. So let's put this all in a single equation, which is let's write here. This whole distance is equal to this distance plus this distance. So this whole distance is V by 2, which should be equal to Vt plus 60 by 2 is 30. Vt plus 30. Now everything is settled. Now let's bring the right terms aside. This is our equation 2. Now let's solve for t. Now let's bring here and this bring here. So 10 will be equal to V into t minus 1 by 6. And this is from this equation, and from this equation I can write 30 is equal to V into 1 by 2 minus t. Now let's say this is equation 3 and this is equation 4. Now let's divide equation 3 upon 4, then I will be getting, or let's divide equation 4 upon 3, then I will be getting 30 by 10 should be equal to 1 by 2 minus t by t minus 1 by 6. This gets cancelled. This is 3t minus 1 by 2 should be equal to 1 by 2 minus t. Now this t comes here. 4t is equals to 1 by 2 plus 1 by 2 is 1, which is t is equals to 1 by 4 hour. What is 1 by 4 hour? 1 hour is 60 minutes. 60 by 4, which turns out to be 15 minutes. So we got t is equals to 15 minutes. So this is the time after which each bus is coming. So this is the time, 15 minutes. Now once you get the time t, you will plug in this equation or this equation, then you will get the velocity v. Should we do this or I'll just leave it for you and you just plug in this value t here. Now you will get the velocity v. T is 1 by 4. T is 1 by 4. Let's do this. V by 6 is equals to V to T is 1 by 4, V by 4 minus 10. Now 10 is equals to V into 1 by 4 minus 1 by 6 is 24, 6 minus 4 is 2. 2 ones, 2 12s. V is 120 km per hour. So T is 15 minutes and V is 120 km per hour, which is option 3. So third option is the correct answer. This is how you solve this question. I got this part. This is quite an advanced question, which I am not expecting from Neet examination. So this is all about the first very tough question of this exam. Let's run this part. Now we got question number 16. Now let's erase this part. Now let's get back to question number 16. How do we do this question number 16? Now there is a sun and whose time period the sun takes 27 days to complete one rotation. By the way, how many days that would take? It is just 1 day, right? So within a day that completes it one complete revolution. But sun takes 27 days. That's what he's saying. Now if the sun suddenly expands to twice its radius, so suddenly the sun is expanding to twice its radius, then what would be its day time would be? Now here, if you look carefully, what you need to do is you need to apply the law of conservation of angular momentum, because angular momentum is conserved. There is no external torque acting on this sun system, so angular momentum is conserved. So I can write I1 omega 1 is equal to I2 omega 2, and I is moment of inertia, which is directly proportional to r square. So I can write it as r1 square, omega is 2 pi by t by t1 is equals to r2 square by t2. Now r1 is r1 square only, and by time 1 is 27 days, which is equal to r2. R2 square is r2 has become twice, so this is 4r1 square into t2. This gets cancelled, which turns out to be t2 is equals to 27 into 4. 27, 7 4 28, and this is 108 days. This is 108 days. Option 3 is correct. And question number 17 is quite easy. We need to find the magnetic field. Use this C is equals to E naught by B naught. So B naught is equals to E naught by C, where C is the speed of light. But don't mistake this C for speed of light in vacuum. Speed of light in vacuum is 3 into 10 to the power of 8 meter per second. But here they didn't mention anything about whether the light is traveling in vacuum or not. So that would be the mistake that you will definitely do if you don't give attention to the electric field equation, because electric field equation is given by Ez is equals to 60 cos 5x plus 1.5 into 10 to the power of 9 t volt per meter. Now what is the speed? Speed of light is C is equals to omega by k, which is omega is 5 by k is 1.5 into 10 to the power of 9. 5 ones 5 0.3. Are we reading this right? Omega is this value. This is omega now, because I am getting omega. This should be omega. Omega is 1.5 into 10 to the power of 9 by 5, which is 0.3 into 10 to the power of 9, which is 3 into 10 to the power of 8. So fair enough. Now we are getting 3 into 10 power 8. So that is all good, because sometimes you might change this. So now this is all good. This is coming out with 3 into 10 power 8 meter per second only. So this is E naught, which is 60 by C is 3 into 10 to the power of 8, which is 3 ones and 320s now, which is 2 into 10 to the power of minus 7. And it should be cos only, cos 5x plus 1.59 into t, and electric field should be along y direction. It should be along y direction, because that's quite simple. Sorry, the magnetic field should be along y direction, because electric field is along z direction, and electromagnetic wave is moving along negative x direction, because equation is 5x plus, so that means the wave is moving along negative x direction. So B should be along positive y direction. Now question number 18. Question number 18 is also interesting. We got two identical, I'll write the question number 18. We got two identical charges. Let's say this is charge Q and this is charge Q. Now let the force between them be F, and the distance between them B. I can write F is equals to K into Q by D square. Now because this is Coulomb's force, F is equals to K Q and Q by R square. Instead of R, we got D. The distance between them is D. D square. This is F. Now what they are doing is they are bringing another sphere. This is initial uncharged. There is no charge on the sphere. By the way, these are charges on spheres. These are spheres which are charged positively with a charge of Q. Now there is another uncharged sphere. Now there is no charge. So first I bring this in contact with this first one. So the charge will be distributed. So this will be Q by 2. And this would be Q by 2. The charge is equally distributed. Now I remove this connection, and now I connect these two. Now the charge will be again redistributed equally. Now the first thing is the charge on this is Q by 2. Now the charge on this is Q. So the total charge is going to be Q plus Q by 2, which is 3Q by 2. Now it has to be divided equally. So the charge on this will be 3Q by 2 by 2, which is 3Q by 4. the charge on this will be 3q by 4. Now we need to find the force between these two charges. Now let's call it as F dash, which is k into q by 2 into 3q by 4 by d square. And this is nothing but 3 by 8 k q square by d square. But k q square by d square is F. So F dash is 3 by 8F. So this would be your answer, which is option 3. Now we got question number 19. Question number 19. In question number 19, what we got is we got electric dipole, and the dipole we need to find the change in potential energy. So change in potential energy is quite direct, which is mv into cos theta 1 minus cos theta 2. So let's plug in these values. mv is 5 into 10 to the power of minus 6, b is 4 into 10 to the power of 5, and cos theta 1 is cos 0, which is 1 minus, and cos theta 2 is cos 60, which is cos 60. How much is cos 60? Cos 60 is which is 1 by 2. And how much is this value? This is 5 4 is 20, 20, 1 by 2, 10, 10, 10 power 6, 1. This is 1 joule, 1.0 joule, which is option 1. Now question number 20 is also direct formula based question, where magnification m is equals to L by f naught into d by fe, which is L is given to be 40 and f naught is focal length of object 2 is given as 2, and distance of vision is 25 centimeters, and the focal length of eyepiece is 4. So this is 4 ones, 4 tenths, and 2 ones to 12.5. 12.5 into 10 is 125. So this is your answer. Now question number 21. 21 is a logic gates question. Most of the people's favorite question. Now first let's draw this logic gate. So this is logic gate. We'll try to do this question in two ways. One is using Boolean algebra, and then we'll try to solve this using truth table. So let's draw the circuit first. This is A, and this is B, and this is A. Now let's find the answer using first. Let's go usual way, which is truth table. Truth table is always good way, because this always tells the truth. That's why we call it as truth table. So you always go for truth table when you are not sure about the Boolean algebra. So let's place A as 1. If you're placing A as 1, and this is 1, and this is also 1, so you're placing 1, 1. Then this 1, 1, this would be 0, and this is 1, this is 1. 1, 1 would be this also 0, 0, 0 would be 0, getting 0. Now let's place A as 1 and B as 0. Place A as 1 and B as 0. So 1 into 0 is 1 plus 0 is 1, but this is NAND. So 1 plus 0, 1 bar is 0, and 0 into 1 is 0, but this is 1. But it doesn't matter, because once you get 0 here, you get 0 here. And similarly, let's try 0, 1. That means A is 0 and B is 1, and B is 1. This is 0, 1, you will get 0 again. Now if this is 0 again, you will get 0. So at last, let's check for 0, 0. This is 0, this is 0, then you will get 1. This is 0, this is 0, you will get 1. So you will get 1. This is nothing but very familiar gate, which we call it as NOR gate. NOR gate, which I can write it as A plus B whole. Now let's do using the Boolean algebra. If this is A, this is B, I can write it as A plus B whole bar and this I can write it as A dot B whole bar, and this output y I can write y is equals to A plus B whole bar dot A dot B whole bar. Now this is something that I don't like to derive. This is something which no one likes to solve, but let's do this. This A plus B whole bar, this can be written as A bar dot B bar. This is De Morgan theorem, and I take the dot, and A dot B whole bar is A bar plus B bar. Now let's use the distributive law. So this is A bar dot B bar dot A bar plus A bar dot B bar dot B bar. Now A bar dot A bar is A bar, and B bar dot B bar is B bar. This is quite important because 1 into 1 is 1, 0 into 0 is 0. So A into A is A, and A bar dot A bar is also A bar. So A bar dot A bar is A bar. So I can write it as A bar dot B bar plus A bar dot B bar. But A bar dot B bar plus A bar dot B bar is nothing but A bar dot B bar only. Same logic, you can check for 1 into 1. Sorry, 1 plus 1, A bar dot B bar plus A bar dot B bar. 1 plus 1 is 1, 0 plus 0 is 0. So A bar dot B bar, and A bar dot B bar is nothing but A plus B whole bar, which is NOR gate. So you can do this in two ways, but I prefer this because this is quite easy and it doesn't require this rigorous mathematical calculations. Now next question number 22. Question number 22, we got a little bit of calculations. We got step, and there is a rod, and the mass of this rod, let's say this is 20 kgs. This is going to be 20 kgs. The force would be 200 Newton because force is equal to mg, which is mg, and this length they have given it as 5 meters. This is 5 meters. So this would be 2.5 or 5 by 2. Now this angle is 60 degrees. Now let's draw the forces. This is, let's say we call it as normal one. This is normal reaction at this point, which is N2. And there will be some frictional force in this direction so that it is balanced. So let's say this is it. Now let's balance the equations. Let's balance the forces. One is the vertical component of forces, which is N2 should be equal to mg, which is 200 Newton. And then if you balance the forces in horizontal direction, then you will get N1 should be equal to frictional force. So this is all you are getting. So this is not necessary, I guess. We don't need this. Now the next thing is, this is not only in translatory equilibrium, this is also in rotatory equilibrium, which means that the net torque acting on this system should be equal to 0. So let's write it here. The net torque about, let's find the torque about this point, because if I try to find the torque about this point, now the net, I need not to consider about the N1, so I will consider the torque about this point. So the torque about this point is first is due to gravity, force is in downward direction, radius vector this, R cross F is going to be inward. So let's do this, and due to this also it will be inward only. R is this, R cross F will be inward, but this R is this, F, this will be outward. So let's equate all inward torque equal to outward term. So inward torque is mg, which is 200 into this length is 5 by 2 into the perpendicular distance. This distance is sin 60. What is sin 60? Sin 60 is root 3 by 2. Root 3 by 2 plus torque due to this, which is a frictional force F, and we got this perpendicular distance. This perpendicular distance, this, which is cos 60, which is 1 by 2, should be equal to torque due to normal force, which is N2. N2 is also equal to mg, which we have just now figured it out. which is 200 into mg into perpendicular distance is this. This would be the perpendicular distance. And how much is this perpendicular distance? That is sin 60. This perpendicular distance would be sin 60, which is root 3 by 2. 2 ones, 200s, 100 root 3, and we got 4 ones, 4, 5 is at 20, but we will be getting 25, 250. Did I do anything wrong? Which is 200, 5 by 2 into root 3 by 2. This is 2 into 100, and this would be 2 into 50. 5 5 is 25. So we are getting extra 25, 250 minus. So I don't think we have to get this extra value because we might be doing somewhere wrong. Because there is also another extra 5 here now into perpendicular distance, which is 5 here. There is another 5 here, so which I am completely missing. So this is 500. Now let's do this. 5 5 is 25. 250 root 3 plus f by 2 is equals to. This is 500 root 3. So f by 2 should be equal to 500 minus 250 is 250 root 3. So still I am getting some extra value. Whether this, there is also another 5 here. So another 5 here. Now this gets cancelled. Now things are going well. This is 500s, 5 gets cancelled, 550s. So 50 root 3 plus f by 2 is equals to 100 root 3. F by 2 should be equal to 100 root 3 minus 50 root 3, which is 50 root 3. So f should be equal to 100 root 3 Newton. So this is also quite a level 3 question which is asked in a previous JEE. This is also, I guess, repeated in JEE mains. So this is all about how we solve this question. Now question number 23, we'll do till 25 and then I'll just have a little break. We will again continue in a couple of minutes. And I haven't slept till now, it's already 5:36. Most probably I will sleep after completing this paper. 23. So 23 is as follows. Let's draw the circuit diagram. As per our tradition, let's keep changing the color. This is 5 ohm, this is 2.5 ohm, this is 3 ohm, this is 1.5 ohm, 6 ohm, and then we got another 1 by 3 ohms here, and then we got 5.5, and at last we got 5 volt here. Now this is the circuit diagram. Now if you look carefully, this is a Wheatstone bridge balanced because 5 by 3. Is this 5 by 3? Yeah, 5 by 3 is equals to 2.5 by 1.5, or I can also do 5 upon 2.5, which is 2, which is also equal to 3 upon 1.5, which is 2. So this is a Wheatstone bridge balanced, which means I can remove this part. So this means I can remove this part. So the effective diagram is going to be something like this. I will redraw this diagram. This would be 1.5 ohm, and here I would get 5 ohm, and this would be 3 ohm, and then here I'll be getting similar kind of stuff with 2.5 ohm and 1.5 ohm, and this is connected to 1 by 3 ohms, and also here we got 5.5 ohm, and this is all connected to 5 volt battery. Now these two are in series. These two are in series. 5 plus 3 is 8. 2.5 plus 1.5 is 4. So you will be getting how much is this? 8 into 4 by 8 plus 4. So this would be 8 into 4 by 8 plus 4 is 12. 4 ones are 4 3s are. So this is 8 by 3. We got 8 by 3 here. And this is 1 by 3. And we got 5 volt. And we got another 5.5. What is 1.5 plus 5.5? 1.5 plus 5.5 is going to be 7. 8 by 3 plus 1 by 3 is 3, 10. So I is going to be V by R, which is 5 by 10, which is 1 by 2, which is 0.5 amperes. This is correct, so it's been amperes. So which is first option. And 24. Now again we got another JEE level question, Tagda question. Let's solve another Tagda question. So I'll grab this part. So here is another Tagda question, 24. In question number 24, what we need to find is we need to find the magnetic moment of an electron in its lowest energy. The lowest energy would be in its ground state, which means n should be equal to 1. That is granted. And here they are given the flux. Flux is magnetic field into area, which is given as n into h by e. N into h by e. Since they are asking about the lowest energy, let's consider n is equals to 1. So we should be equal to h upon e. So b into a is equals to h upon e. So from here I can write b is equals to h upon e into a. This is my first equation. B is equals to h upon e into a. Now let's figure out another equation. Now if you look carefully, the force acting on this electron is only the magnetic force, which is F is equals to Q into V cross B, and which is equals to mv square by r. So net force is equals to Q is equals to mvb, which is equals to mv square by r. Because there is no electrostatic force, this electron is moving in the magnetic field. Due to this magnetic field, that any charged particle in a magnetic field can take this circular path. So here this is moving in circular path. F is equals to mvb. So bqv now should be bqv. I'm sorry, b into q is nothing but charge of an electron, which is e. BeV is equals to mv square by r. V gets cancelled, and what we would get? We would get V is equals to BER by m. BER by m. This is our second equation. Let's write it as first equation. Let's write it as second equation. And then what else we got? And then now this is your first equation, and this is your second equation. Now I need to find the magnetic moment. Magnetic moment is given by I times A, I into A. And what is I? I is nothing but Q by T. So I is nothing but Q by T. So that is E by time period. Again use this T is equals to 2 pi R by V. So again I am using this 2 pi into R by V comes in numerator into area. Now let's substitute the value of V here. So this is E by 2 pi R. Instead of V, I will substitute here B E R by M into A. Now again, instead of B, I will substitute H upon EA. So this turns out to be E by 2 pi R times ER by M times A times, instead of B I am substituting H by EA. Now if you look carefully, the things are going to get cancelled. Now A gets cancelled and R gets cancelled and E also gets cancelled. This E, one E gets cancelled, there is another E. So now we are left with HE by 2 pi M. This is your answer. HE upon 2 pi M would be your answer. This is how we solve this question. So yes, this is a quite an advanced level question. See, you need to find magnetic field and substitute in the velocity and substitute this here to get the time period. Once you get the time, you find the current. Once you find the current, you find the magnetic moment, which is I into A. See, this whole process is quite a headache. Now let's move on to the next question. And next question is question number 25. Question number 25 is graph. In the graphs, if you look carefully, the only option A is correct. The graph, this graph is given in NCERT. Photoelectric current. I will write it as photoelectric current PC. This is photoelectric current. This is not how it represents, but still I write it as I. But don't get confused with I again. Here. This is intensity. Now the plot should be a straight line passing to the origin. Now option B is wrong because once you are choosing option A, there is no way you should be choosing option D. That would be contradicting. And option C and D are ruled out because photoelectric current does not depend upon the frequency of the light, but it depends upon the intensity of the light. If they have given kinetic energy, then option D would have been correct. Instead of photoelectric current, if there would have been kinetic energy versus frequency of light, then it would have been correct answer. So the correct answer is option 4. Again, we'll do from question number 26.